Sir, very good morning, sir. Silas, sir. Thank you, sir.
Good morning, sir. How are you?
Yeah, fine, sir.
Fine.
Say 5 minutes, sir. Just 5 minutes.
Yeah, no issues.
Okay, thank you. Good morning, sir. Good morning, sir.
Sir, our speaker has come, sir.
Yes, sir. Yes, sir. Came, sir. Already came, sir.
Good morning, sir.
Yeah, very good morning, sir. Very good morning.
Yeah.
Welcome to our conference, sir.
Thank you.
Professor, introduce பண்ணிட்டீங்களா?
Yes, sir. Yes, sir.
Very good morning to all the delegates, respected speaker of this session, Keynote speaker. I sincerely welcome our chief speaker of the third day COMAT 2023 session. Welcome, sir. I also welcome all the delegates to the third day of the COMAT 2023. A very good morning to one and all. I now welcome our convener, Professor Bala Muralidharan, to introduce our speaker. Yes, sir, please.
Okay. Okay. Good morning to all. Dr. Sailesh Iyer, Professor and Dean, CSC, IT Department, Roy School of Engineering, Head, Collaboration and Tie-up, Roy University, Ahmedabad. Sir has completed PhD and postdoc from USA and currently working as professor and dean with Roy University, Ahmedabad. He has more than 23 years experience in academics, industry, and corporate training, out of which 18 years are in core academics. He has been awarded Research Excellence Award for years 2021 and 2022 by Roy University and an honorary adjunct research scientist at Neurolab International under Dana Brain Health Institute, Iran from 2022 to 2025. He has several patents granted and published and to his credit and is involved as an editor for various book projects with Elsevier, IGI Global, CRC Press, Taylor and Francis, Bentham Science, etc. He has been invited as keynote speaker in various international conferences held in China, Indonesia, Philippines, Saudi Arabia, Haiti, Ukraine, Italy, and India. A hardcore academician and administrator, he has excelled in corporate training, delivered 150 plus expert talk in various AICT sponsored STTP, ATAL, FTPs, reputed universities, government organized workshops, orientation and refresher courses organized by HRDC, Gujarat University. Research contribution include reputed publications, uh, track chair at ICDL AIR 2020, Springer, Italy, IC Softcam 2020, IEMIS 2020, Springer 2020, IEEE, ICRITO 2020, IEEE, ARISC 2021, FTSC 2021, and TPC member of various reputed international and national conferences. Reviewer of international journals like Multimedia Tools and Applications, Springer, and Journal of Computer Science, Scopus Indexed, International Journal of Big Data Analytics in Healthcare, IGA Global, Journal of Renewable Energy and Environmental, and editor in various journals. Expert talk on research-based topics in various universities and conferences, in addition to guiding research scholars as supervisor. He has as he has also been invited as a judge for various events, examiner for reputed universities, is a Computer Society of India lifetime member and also managing committee member CSI Ahmedabad chapter 2018 to 2020. His research interest area as computer vision and image processing, cyber security, data mining and analytics, artificial intelligence, machine learning, blockchain, etc. Sir, very warm welcome to our conference, sir. Please take this.
Yeah. Thank you very much, sir. I hope I am audible.
Yes, sir. Yes, sir.
Fine. Okay. Actually, we are just, first of all, before starting with my presentation, I would just like to congratulate your team for organizing this excellent conference of 3 days, and that too at a time when we are ending the year of 2023. So we are ending on a very high note with a lot of research ideas, networking, and a lot of presentations. So I think so there's no better way to end the year than have such a wonderful conference over here. So congratulations to the team. And I'm just again trying to share my screen.
Yes, sir. Yes, sir. Sure, sir. Thank you, sir.
Fine. I hope the screen is visible.
Yes, sir. Yes, sir.
Fine. Basically, I would just like to sum up the introduction. It was too long, actually. I needed to give a small introduction when I was asked for the profile. But yeah, I would just like to say that for every researcher, for every academician, just two terms are very important. That is important for me also, that I am a good collaborator and a good learner. So I think so these two words are summing up. Balance is the number of years of experience you add to your profile and the work that you do. But ultimately, the key is collaborations and learning. So if these two continue, I think so we'll be moving to great heights in the future. Now, coming to my topic, actually, I had a few topics in mind, but yeah, digital twins is one more very topic which is very close to my heart, because we are working and we have just submitted a book with almost 27 chapters to Elsevier regarding digital twins, which is under publication. But I understand the speaker after me, that is at 10:45, is scheduled to take a topic on digital twins. So I just shifted to research trends in computer science. So I would be focusing on things other than the digital twins, because that would be covered by the other speaker. Now, these are some things that I want to cover in today's presentation. First is that research ideas evolve from UN Sustainable Development Goals. So I would just like to focus upon that a little bit. Use cases of AI, artificial intelligence, smart devices for healthcare. What are the research and innovation domains in computer science, and the trends and challenges in computer science? So I'll be focusing upon most of the areas where computer science is being used. So like this is a very strong and very famous presentation slide, which I make it mandatory that it should be in most of the universities. Whenever the professors are teaching any subject, they should be taking this to the students, because this is very important for students and researchers to understand that research should be connected to the use cases. So when we talk about use cases, actually there are 17 UN Sustainable Development Goals, which are also known as SDG. Now, how can computer science, how can research contribute towards these areas? That is what we need to look into. Right now, we see that a lot of publications are happening, but a lot of research is going on, but the output is that they are not connected to the use cases. So this is one area which I feel needs to be improved upon. So first one is no poverty. That means what the UN says, that there should not be any poverty. People should not be poor. They should be earning reasonably well. That is what we are looking at. Now, how can research areas in computer science help towards that? So that should be a matter how we should be brainstorming it. Zero hunger. This is the second one. Most of them will say that, okay, no poverty and zero hunger actually is connected directly to the trends or the policies of the government in place. But yeah, how can we contribute as academicians, as researchers into this domain? That is also a very important thing. Now, zero hunger, there are a lot of apps, there are a lot of there are a lot of such applications which are actually contributing towards zero hunger, because whatever food in the restaurant is there, that is being circulated to the needy people in a proper manner without actually damaging the standards of the food or the quality of the food. So this is what zero hunger is all about. So how can we more contribute towards it? That is one thing which we can think about. But yeah, third and fourth area in particular, third and fourth goal is very important, because good health and well-being is one of the most important criteria post-COVID that we are working upon. I did my postdoc in medical imaging, so I know what are the healthcare trends and what are the healthcare focus areas that needs to be maintained. But now preventive healthcare is something that is very much evident. Preventive healthcare means what? That suppose if I'm having, suppose I have crossed in particular age, I am 40 plus, suppose, then how do I deal with my health problems? Even if I don't have a health problem, how do I take care of the health? How do I prevent from any diseases coming to me? So I have to have some preventive healthcare measures. It may consist of devices, small devices which are attached to my body, or which can be in the form of a smartwatch. Just like simple can be that there have been a lot of devices in the market which actually, uh, if they are just on your body at any place, it may be in the form of a watch, it may be in the form of any wearable device. It tells you what is your vital parameters, blood pressure, sugar, etc. These are the basic trends that needs to be monitored. But depending upon some of the, I'll be showing you some examples also where such devices, such innovations have taken place, where people, how sound the sleep of a person is. Because normally we go to sleep at some people go to sleep at 10, some 12, some don't feel sleepy. So what are the problems? Even when you sleep, how sound your sleep is. Because suppose if I am sleeping but I'm disturbed during the sleep, then that also would be monitored and that would be notified to my doctor also the next day. So doctor also has a track record on how my sleep parameters are. Is it sound sleep, quality sleep, or is it disturbed sleep? So if disturbed sleep is there, then what are the problems arising? That can be detected. So these are all things that we talk about in well-being. So healthcare is a very important parameter where I think computer science, IT can contribute. And in this, AI, IoT, cloud computing, digital twins, all this can play a very important role. Sorry. Quality education is one more important thing, because this was one project which, like one of my scholars, we were working on adaptive learning and smart solutions for quality education. So we had submitted a project also to Guj Coast, wherein I did an entire survey of the education sector. Now, in this rural education in Gujarat in particular, we had taken, because we are based in Gujarat. So it was found that in 2017-18, there was a statistics survey conducted wherein all the Gujarat rural area schools were surveyed. And it was found that students were not responding, or their level of education was not as per the expectation of what their standard should be. A fifth standard student should be knowing this much, but that was not being covered. So then what were the reasons that we found out? And we understood that, okay, a lot of duties are being given to teachers. Teachers are in shortage, they're primary school teachers. And those who are given duties also, those are teachers, appointed teachers, they were also given other duties like counting, election work, a lot of other things. So they were not able to concentrate on the academic part. So we thought about a humanoid robot which can be an assistant to a particular teacher. But again, the problem was that these humanoid robots are very costly. So affordability is a problem. So now we are looking at solutions where we can have a cheaper robot below a cost of almost 40,000 or 25,000, with all the facilities that a small teacher can give. So we are working on that model. It's difficult, but yeah, that is one thing which I think can change the entire way the education is being delivered. It cannot replace teachers, but yeah, it can be added supplement to the teacher. So in the teacher's absence, or when teachers are short, there we can use this particular concept. Then fifth is gender equality. Again, that of course we can deliberate what all can be done, but yeah, that is not, I think that is not a major area where computer science can contribute. Clean water and sanitation. The sixth one is very important, because clean water is one of the basic rights that we should have, and sanitization. So sanitation is very important criteria here, and how we are working towards ensuring this, not only saving water, but also providing clean water as far as our regular drinking needs are concerned. So a lot of villages are not getting clean water. They are getting it from the nearby wells, etc., but they are not clean enough, not drinkable, right? A lot of diseases occur due to that. So how can we deal with this? That's a very important question, and how we can go about it. So here IoT can play a very important role. AI can play a very important role. So I think so these solutions can also be provided. Seventh is affordable and clean energy. That there is one more book of mine which is considered, which is dwelling on, which is already Scopus Index, which is on renewable energy and AI for smart applications. So here, what we are dealing with is affordable and clean energy and how it can be delivered, how it can be ensured. So a lot of work can be done on that areas also. Eighth is decent work and economic growth. Now, again, here we can debate what all can be provided, but yeah, I would not focus upon that area right now. Ninth, industry, innovation, and infrastructure. A lot of things can be automated here. Now, when I post COVID, I was just doing a survey of the research topics that are very prevalent. So, what I found is automation was one of the most relevant topics. Industry automation, healthcare automation, that was very much on the agenda of the government as well as the private players. So I think so a lot of work needs to be done on this domain. And here I think so industry, innovation and infrastructure, digital twins, including AI, IoT, etc., can play a very important role, robotics, for delivering this kind of a mechanism. Reduced inequalities. One of my favorite is the 11th one, which is sustainable cities and communities. There, I think so. Lot of, we are talking about sustainable and smart cities and villages. So there again, a lot of work can be done. Smart farms can be built up. Smart cities can be built up. We can have waste management taking place. So a lot of such opportunities are there in this domain where computer science can be used. But yeah, that has to be used with a lot of judicious optimism, because just now recently our transport ministry, there was a statement from the minister saying that we will not allow autonomous vehicles, autonomous self-driven cars in India because drivers would lose their jobs. Now this is a very impending question, and it also raises a lot of problems or debate from a lot of people saying that okay, automation, has it led to loss of jobs or not? So that's a debatable topic. I'm not siding on anyone's area, but yeah, a lot of automation has taken place up till now, and it has not resulted in any kind of job loss, but it has increased the skills of the person, and that has resulted into better opportunities and better efficiency for the individual. So I think so. A lot of government mechanisms also need to work on this domain. But 11th is one of the very emerging areas of where research can play a very important role, and particularly computer science in general. Consumption and production is also one of the, what we produce, is it going to lead to a responsible society? Is it going to be consumption driven, which is going to be healthy for the individual, or is it going to lead to a lot of other problems? So that also needs to be looked into. Climate action, a lot of work is going on right now, so I'm not going into that topic. Below water, life below water, that is ocean, the kind of quality that you're maintaining in the oceans, so that needs to be taken care of. Life on land, again, very important. Are we going to give a legacy to our future generations where they can say that no, our ancestors had given us something that we are enjoying right now? Or do we give them masks? Do we give them oxygen masks for breathing? Do we need batteries for kind of people to perform? So these are all things which we need to look about. So life on land is again life below water, life on land. All these are parameters which we need to focus upon. It gives me one more interesting topic I would like to just share with you. When COVID lockdown was there, 3 months of lockdown. Sorry. So at that time, actually, there was such a condition wherein like a lot of small lakes, rivers were polluted. So during the lockdown, there was a survey done by some of the people just once the lockdown ended. During that time, it showed that a lot of species of birds which were not found normally on the rivers, near the rivers, were found because of the clean water that was provided during these 3 months. So when people are not polluting the water, then there are species coming into domain which you have not seen. Again, after few months post lockdown, when this again the same region was surveyed, it was found that such species did not turn up during that time. So a lot of birds are going away from us because we are not providing them a clean environment to stay. Same is for our future generation also. Are we providing an environment which is safe, which is healthy? That needs to be looked into. And how can technology contribute towards that? That's a major thinking point. Peace, justice, and strong institutions. Again, laws needs to be framed, because now we are going for automation. So there are a lot of frauds happening. How can we deal with the cyber laws? All this needs to be looked into. And partnership for the goals, collaborations and partnerships between various stakeholders. So these are the 17 sustainable goals. And if I think so, the slide itself can throw up a lot of ideas to researchers on how they can contribute or which area they want to contribute to in research. This is one pertinent problem. So I'm just putting up use cases right now, research trends where you can contribute towards research. These are areas where we need to manage this thing in a very important priority manner, because traffic is tremendous. Traffic jams are a serious problem. Honking is a serious problem. How can we deal with traffic and parking? If this can be worked out, I think so a lot of problems can be solved. So for that, a lot of mechanisms have been suggested, like there have been algorithms, AI algorithms which have been implemented, which can suggest you the route where the most traffic is there, so that can be avoided, and some routes where less traffic is there, and that can be taken. And also it can calculate the area covered, that is the distance covered, and the additional amount of fuel you require, etc. So all this are available, but what can we still add into? That is an area of research. Now, if we are not able to care about two sections of the society, then I feel any technology is of no use going forward. First is elderly people who are actually above 60, senior citizens we call them, and children below 18. So if we are not able to care about the facilities regarding these people, then I think so our technology is not sound enough. So for this, actually, there are various mechanisms which have been there, including wearable devices, as shown here. An old man is actually, he has just fell down the stairs, and immediately the doctor has been notified, ambulance comes, and it has been, the treatment is being given to the patient. So here, there is no need for anyone to stay along with the elderly persons. There are devices which can notify. So I believe this healthcare is going to be a major area of research, and AI is going to rule the roost for the healthcare sector. So these are all some sectors on which a lot of work is being done and a lot of work can be done. I would like to or rather classify it into predictive analytics, healthcare analytics. It can be diagnostic, and it can be future trends that we can predict. And currently what is going on, that patient monitoring system, that also can be there. So three kind of analytics systems can be developed using AI. So AI can be used in drug development, medical diagnosis, dosage error reduction, cancer research. Cancer, I'll show you some slides what all work has been done. It's really an achievement that we can say. Health monitoring and wearables, this is a very important sector which is growing up. I'll show you some of the examples of that also. Cybersecurity, fraud detection, AI robot assisted surgery. Now, some people may actually say that, okay, there is a robot. How can that robot take the role of a doctor? What will happen to the doctors? No, just like we talk about autonomous vehicles, where drivers are not available, that autonomous vehicles can play a very important role. Similarly, where doctors are not available, AI robots can do the surgery. This is an example, actually, wearable brain scanner. Now, earlier we used to have a kind of, if you have to have a scan, then we have to go into a room, and that room consists of an MEG scanner, which is a big device, which is close to 450 kg. 450 kg, and the sensors needs to be kept at minus 2, almost 269 70 degrees Celsius. Cooling equipment is required. You cannot carry your mobile. You are not able to move here and there. If you move your head, then it can lead to a lot of problems. So you have to be stagnant for some time. So all this needed to be done earlier. Now, right now, we have a portable MEG device which has been tested, which weighs less than 1 kg. This is just a diagram of that. The patient can move around inside specially designed room that can counteract the influence of the Earth's natural magnetic field. So this is something which we think is the advancement that we are looking at. And for babies, children, we cannot dictate them that not to move, even for elderly people. So this can be a very real boon wearable brain scanner, which can play a very important role. But only here the cost needs to be reduced. So that is a challenge. So wherever research is there, computer science is there, there's always a challenge that how can we reduce the cost and make it affordable. If it's affordable, then we can have bulk production, and that can lead to a lot of solutions being created. Same way, ultrasonic device to capture blood pressure levels. So this is again one very important device which is prevalent. Smart contact lens for detecting glucose levels. So again, this is an advancement which we never thought about. This is something which is very important, ingestible pill sensor system. Now, if you want to have some kind of a scanning of your stomach area, you can say, then this is a mechanism. Earlier, like any kind of operation needs to be performed. I forgot the technical medical terms for that, but yeah, when operation is to be performed, there needed to be a tube which need to be passed through the stomach, and then that fetches the data, and then that can be used. But for that, that's very painful. That's very time consuming and costly. Now here there is a pill, which is a smart pill, which can actually be ingested, and through that pill everything can be demonstrated, and the mobile phone, all the data can be available on the mobile phone, and this pill will actually dissolve. So it's not that you need to take it out by some other mechanism. So that is a dissolvable pill. So this is something which is an advancement, I call, and this is an industrial pill sensor system. In medical imaging, a lot of advancements are there, and this is what I believe. This is the organized market I'm talking about. Organized market is by 2031, the CAGR is expected to be 40.3%. So that's a huge amount. Comparatively, if I just check the unorganized market, because in India, in many other countries, there is a lot of unorganized market, which is not actually, the statistics are not available. So that medical imaging market is huge. So I add another 20% to this. So 60.3 CAGR can be the return that can be predicted from this. So there's a huge market. There's a huge demand for such products which are related to medical imaging. I was talking about cancer. This is one very important development. I would just like to compare it with, I've just gone through a case study and I've decided that this is which is better. So when I just gone through it, there is a MD. He is a radiologist with 15 years of experience, and he was given a kind of a picture of a particular prostate cancer related image, and he highlighted in that, which is the, along with his 15 years of experience, he has highlighted that these are the areas where the cancer is creeping, growing, prostate cancer is present. Same way, an AI based computer program has done the same, and the results are nearly identical. Close to 99% accuracy has been achieved. So you can see there have been a lot of questions being raised on the accuracy, etc. Same can happen for human being also, but yeah, how we deal with this is a very important thing. It may be required that we may need to train the AI based computer program to do the same things that the doctor can do. Of course, doctor is not replaceable, but yeah, it can be supplemented. So we can use such kind of cancer imaging tests and such computer AI-based computer programs can be used to detect whether a cancer is there or it's just a harmless lump. If it's cancer, how fast it's going, how fast it will spread, and how much time it will take for treatment, and is it going to be a last stage of cancer or not. So all this prediction mechanism can be done with the help of AI. Now, this is one area where a lot of work is currently going on. Like Google has tied up with a particular local hospital in Madurai called Arvind Eye Hospital in 2018, where they were actually working on. There is a this Madurai Arvind Eye Hospital. That doctor is famous for the maximum number of cataract operations that he is doing in a day. So they have Google Healthcare arm has tied up with this hospital, and they are providing an algorithm with 97 to 98% accuracy for predicting this eye-related ailments. So this is something which is a development which I feel that should take place, and that should actually change the entire way how we are dealing with these issues. So I would not like to go into this because this is a particular case study which was regarding glaucoma and diabetic retinopathy. But there's a huge demand here, and we believe that the cases will increase to 95 million by 2030. So we need to look at this in a big way. This is how shopping is going to take place in the future. So can we provide solutions for this where there is no human interaction? Everything is starting from the product selection to billing, everything is done in an automated way. So this is an IoT application scenario. These are some of the advancements that have taken place. This is a happy fork. This I'm just highlighting because these are the use cases where a lot of work is going on. So from here, the research ideas are being generated. This is a happy fork, which is an electronic fork that helps you monitor and track your eating habits. Some people are very selective about their eating habits. They are dieting. They want to know what is the ratio of the calories that they're taking and etc. So for that, this happy fork is a very good solution. Glucose monitoring system, again, very important, right? Smart washing machine. This is again with a lot of use cases. There's a smart refrigerator also, which what it does is that it gives you an idea regarding right now husband wife both are working. They don't have time for after coming back from office, they just want to, they are very tired. They don't want to actually go and peep into the refrigerator, what is there, what can be made, etc. So the smart refrigerator will give you an idea on your mobile. It will give you a notification saying that these are the ingredients that are present in your refrigerator, and you can make these recipes based on that, and the recipe will also be given. And also it will be giving you an order regarding indicator that these all items are less in stock in the refrigerator that needs to be ordered. So it will help you in maintaining your because there have been a lot of issues arising because of this. Husband and wife both are working. Now there may be some internal squabbles, fights, because husband may say that you do this, wife may say you do this. So refrigerator is providing you solutions where internal scuffles can be managed very aptly, and there may not be any kind of deliberation. So this is again one human angle to what we are talking about. Blood pressure monitor, again, this is a very important development. Smart weather station, it will give you all the predictions, especially those who are very health conscious regarding climate and weather. Smart socks, there are a lot of devices in this domain which will actually give you how much you have walked, what is the counting speed, accuracy, everything, step counting, everything will be given to you on your mobile app. So this is again one more development which I was talking about earlier. Your sleep pattern can be analyzed. This is specifically for right now. A lot of young generation is facing this problem, and also elderly people are facing this problem who are having medical ailments. They are facing this problem that they are not able to get sound sleep. So they have anxieties, lot of issues are there. And post-COVID, this has increased a lot. So how can we deal with this? So there is a sleep monitor which will tell you how soundly you have slept. So your sleep patterns are being monitored, and that analytic dashboard will display everything. So this is a wearable device through which all the statistics of your sleep can be shared. This is one more thing. Again, I'm not sure how this can be implemented in India, because there are a lot of other legal parameters. But yeah, uh, this is one important thing which, yeah. Can IoT help us to know more about ourselves? But this can be misused by the people if it is in other people's hands. So like, where you are going, whom you have interacted with, how long you have spoken to friends, the affinity of connections, everything is available on the dashboard through IoT. But the major concern is, if all the statistics is available in somebody else's hand regarding your habits, then your unique identity would be in threat, and you would be facing a lot of problems, because somebody else can govern the way you are going to act. They know already what can distract you. So if they are not happy with your progress, they can do something to distract you, because they know all the mechanisms, all the vital details about you. So this is something which I feel is subject to legal and ethical considerations. But yeah, this can be, IoT can help you in your life logging. If it is used perfectly, then I think so a lot of suicide cases can be prevented, because this will give an idea regarding what all the person is going through, and that can also lead to counselors counseling at the right time. Thought controlled computing, again, I told you that this is something which is very much, I mean, EEG is something which is very much research right now, but I'm not sure regarding the legal considerations, because there are a lot of legal challenges which may come up in India. This is a very close to my heart, because I feel that if India needs to progress, if the world needs to progress, then agriculture needs to progress. So agriculture, if it is automated, it can make a lot of changes. We should not have an image of a farmer who is toiling in the fields, who is dependent upon rain, who is dependent upon seasonal conditions, who is not having crop related knowledge, soil monitoring mechanisms, who is not able to diagnose diseases and provide solutions to the plants. So all this is the image of agriculture right now in India, that agriculture is very painstaking. It's not modernized. But I'm looking at such a situation, 2030. I'm not willing to wait till 2047 also. If we all contribute towards this, if we adopt and provide some smart solutions using our research potentials in these areas, I think so crop yield production and price forecast can be done, intelligent spraying can be done, predictive insights on what is the right time to sow the seeds for maximum productivity, everything can be created and given to the farmer. Using autonomous robots for harvesting, crop and soil monitoring, and disease diagnosis. So all this is possible with the help of this. And this is what I feel is going to be the future of farming. Now, this person who is sitting here is sitting in his office, or maybe in his house. This is his house basically. And he's a farmer. He is not a corporate employee. He's a farmer who is monitoring the entire operations of his farm through a dashboard, right? So he has a desktop here, or a laptop maybe. He is monitoring everything with the help of this. He is able to get the farming data at his fingertips. He has cows which have been RFID tags are there, and through that all the details are going through to the farmer, where the cows are, what they're eating, where they're going, etc. So he can control that. Smart tractors are there, which are going to be again autonomous tractors which don't need a driver. So again, farmer is sitting in his office and he is guiding the tractors from his laptop. Fleet of agri-boats, right? They are again capable of a lot of mechanisms. Fertilizer reduction can be there because of this, because they know where to spray the fertilizer, where not to spray the fertilizer. Survey drones are there, right, which actually are mapping a lot of parameters. So this is something which I feel is going to be the future of farming. And if this is If hardly, I mean, I just tell to my students and researchers that if 100 smart cities and smart villages are implemented by 2030, there'll be a huge potential, huge growth for India as a whole, and specifically the rural areas. So this is going to be the future driving force behind this. Smart jar, again, all the recipe details, everything can be going from this particular thing. So there are a lot of such issues. Now this is a smart city dashboard where everything can be managed by maybe the government. If it is installed in a society, and society people can monitor it. I can monitor my water usage. I can monitor my waste management system. The society can monitor the waste management, water management, street light, everything mechanism of that particular society. If it's in the municipal corporation can manage everything at their fingertips. So this is going to be the future going ahead. This is very soon going to be a reality. This is the monitoring mechanism I was talking about, right? This already CCTV monitoring is being done, but that is going to be still smarter. So what are the challenges in ML, machine learning on wearable devices? These are some of the challenges which we have right now, which we want researchers to work on these areas and find out solutions. Storage limitations are there. So storage is costly also. Data availability and reliability is a question mark. Model selection and reliability needs to be challenged at every step. You need to ask questions when you're researching whether your model selection is okay or not for this. Can it be still better? What is the reliability percentage? Deployment alternatives needs to be checked. That is a major challenge because many things are not able to be deployed. Security and privacy considerations are there. User acceptance is a major challenge. Power consumption limitations are there. So there are huge challenges which are existing in wearable devices, and that is why India has not still picked up in the way it should pick up in this domain. This is again 82% of the enterprise fail to scale AI and achieve meaningful business outcomes. So I really link this research with the outcome. Because if I say that, okay, I have developed X thing, but it is not being implemented in real life in the areas where I have implemented it for, where I have developed it for, then there's no meaning of that particular invention, that particular research. So these are the some of the problems which are the common AI challenges regarding the implementation part. Fund is lacking sometimes. Sometimes enterprises are struggling to align their strategies in business context. Sometimes it is too much oriented towards society, but no gain from for the company that has developed it. So a lot of challenges are there. So company is not keen on developing that. But what can we do? I'll just end up with one small kind of you can say suggestion, or I would like to take your suggestion in this, or a small advice from my pattern would be that as academicians, as professors, as researchers, are we doing enough for the society to respond to us? Because what we are doing is for our academic API score. Can we adopt 5 villages nearby and can we provide them solutions? That is enough. We don't need to do it big. Can we tie up with big companies who can sponsor such projects? Probably possible. So this is all I would like to just stop by my introducing some ideas to you. So this was what my focus was today. Thank you very much for the patient hearing, and I would once again like to congratulate the organizers for having this conference at this particular time, because it's a very critical period of 23 where we are looking at many solutions, and also for inviting me as a keynote speaker. Thank you.
Thank you, Professor. Thank you very much for the wonderful talk, keynote speech. Really, we are very happy to observe the lot of things you have presented. Particularly, the talk was trying to solve all the problems currently faced by the society, and most part of the presentation was towards achieving the sustainable development. What happened to the birds which were earlier visiting us, and how to handle a surgery in the absence of a doctor, and in future how we are going to manage the farms even in the absence of individuals or caretakers. So like that, a lot of things which were real, and the finally you also pointed out that if we are able to adopt 5 villages, so that will be the success of the invention. So all these were really societal based. So this presentation was really very thought provoking to all of the young researchers and also all the participants, I hope. Thank you very much, Professor. Thanks a
Thank you.
lot for joining us. I am as the conference chair, I thank Dr. Shailesh Iyer for his keynote talk, which has made a lot of things to think about it. So I I welcome Dr. Balamuralidharan for his comments. And if any questions from delegates, you can please ask Professor, or you can even send the questions to his mail ID that we will provide. Thank you,
Yes,
sir.
sir. Already, sir posted.
Sure.
Already, sir posted
Yeah.
in the text box.
Yes.
Sir, mail ID.
Okay.
Sir, lot of unknown information we received, sir. It's very informative. Thank you, sir. Wonderful talk, sir.
Thank you. Thank you, sir.
Thank you, sir. Any other question from audience? Any other questions from audience? Sir, we got lot of real life applications, sir. Thank you, sir.
Yes, sir.
We
Thank
are
you.
very
Thank
much.
you. Thank you, Professor. Thank you very much. Thank you very
Thank you.
much for
Thank you.
joining us. Thank you.
Ma'am, Tulasi madam, very welcome, madam. Very warm welcome to.
Thank you, sir. Good morning, sir. Can you hear me, sir?
Good morning, madam. Hearty welcome to you, madam.
Thank you so much, sir.
We welcome Dr. Tulsi for delivering the invited talk, and I am I am here to inform that due to unexpected situation, Dr. Vijay Antale is not able to join us because of his sudden illness. So, in that way, here we are fortunate to have Dr. Tulsi, who is going to deliver an excellent talk to us. We welcome, madam.
Good morning, sir.
Kindly start.
Yeah, thank you,
madam.
so much.
Thank you. Once again, madam, Dr. Balamuralidharan, kindly make an introduction of the speaker.
Tulasi Pikku, Department of Computer Science and Engineering, School of Computing, Amaravati, Amirda University, Guntur, Andhra Pradesh. Today, ma'am will deliver on improved quantum algorithm, a crucial stepping stone in quantum powered drug discovery. Ma'am, please take over this session, madam.
Thank you. Thank you, sir.
Thank you.
Good morning, all. This is Dr. Tulasi Bikku. I'm working as Associate Professor in the School of Computing, Amrita Vishwavidyapeetham, Amravati. And today I'm going to discuss about improved quantum algorithm, a crucial stepping stone in quantum powered drug discovery. And coming to the abstract which I have worked on this particular area is quantum computing. As of now, quantum computing leverages the principles of quantum mechanisms to perform computations. And you all know about the quantum computing, which is very fast and effective than the traditional classical algorithms. And unlike classical bits, quantum bits and qubits can exist in multiple states simultaneously. It means if you take any bits, it will be 0 or 1. In the quantum bits or qubits, you can see both zeros and ones in the same bit, and both can take the values, and they can give more accuracy than the traditional algorithms. This enables quantum computers to explore many solutions at once, potentially solving certain problems much faster than the traditional computing. So that's why quantum computing came into existence. And the key concepts include superposition, entanglement, and quantum gates. These are the things which quantum computing mainly works on this. And however, practical quantum computers are still in early stages of development, facing challenges like maintaining qubit stability and error correction. Because the quantum computing really need an environment which should not affect the external environment should not affect the internal computing of the quantum computing. So that is the main challenge today in today's world. And coming to the my work is today I'm working on the drug discovery. By here I'm going to provide a robust framework which can accelerate and for the identification of new and effective treatments. And drawing inspiration from quantum mechanics, quantum algorithms overcome the limitations of traditional computings, enabling comprehensive simulations of molecular interactions. This approach offers remarkable insights into the molecular dynamics and quantum chemistry, streamlining drug discovery process. Despite being in early stages of development, these algorithms show promise for the transforming pharmaceutical research. Critical challenges such as noise reduction and algorithm optimization need to be addressed in this quantum field for providing positive computational consistency and improved efficiency. And I have introduced a new framework which can give very good accuracy than the traditional algorithms. And I have taken some of the quantum algorithms also and compared with the proposed quantum neural network. Overcoming these challenges will lead to the revolutionary advancements, empowering precise simulations of molecular interactions and establishing the groundwork for sophisticated and selective drug discovery methodologies. The proposed model and embedding in the evolving quantum landscape, holding the potential to outperform standard machine learning and promising transformative outcomes in the drug development. So this is the abstract I'm going to discuss my work which I have done in the quantum drug discovery. And coming to the introduction part, in the ever-evolving landscape of drug discovery, quantum computing emerges as a transformative force promising to revolutionize the way we approach the complexities of molecular interactions. Here, the quantum computing holds promise in drug discovery by rapidly simulating the molecular interactions. And its ability to process complex computations simultaneously can analyze various molecular configurations, potentially accelerating the identification of new drugs. Here, based on the structure and arrangement and biological structure of the human, we are able to identify the requirement of the drugs. And based on the molecular interactions among the drugs, also we are able to provide the drug which can recover the human fastly. That is what my experiment want to show. Quantum algorithms like those for optimization and machine learning enhance the efficiency of searching vast chemical spaces for optimal drug candidates. Despite the challenges, integrating in the quantum computing into drug discovery may revolutionize the field, offering novel insights and expediting the developments of therapeutic solutions. Here, coming to the significance of quantum computing, the traditional computing which cannot perform efficiently, which are unable to provide the accuracy in the molecular interactions. So we are going to use the quantum mechanics principle in the solutions to these challenges. And coming to the limitations of classical computing, expands on the challenges classical computing faces in modeling complex molecular interactions. Coming to the classical computers limited by the binary bits. Here we are able to use the qubits and we are able to struggle to capture the intricate dance of molecules in biological systems. That is the main limitation of the classical computing. Coming to the introduction to quantum computing, introduces a quantum computing as a solution to all the previous limitations of the classical algorithms. So we are introducing the quantum computers which can leverage the quantum mechanism principles and allowing for more efficient simulation of the molecular interactions. And we are having some limitations with the traditional classical algorithms traditional classical computing faces limitations in drug discovery due to the complexity of biological systems. as we all know that the complexity of the biological system is more, because we are having some gene sequencing also comes under this drug discovery. Some key constraints include computational complexity. As we know that classical computers struggle to efficiently handle the intricate calculations required to model the behavior of large molecular systems, and limiting their ability to simulate the complex biological process accurately. That is the main one of the main drawback we are observing in the classical computers. And the processing speed of the classical computers also very low. In the drug discovery involves exploring vast chemical spaces and simulating numerous interactions. Classical computers may take a long time to analyze these possibilities, slowing down the drug development process. That's why the classical computers, the process of drug development is taking so much of time, and it is slowing down the computational process also. Coming to the scalability, as the complexity of the drug discovery models increases, classical computing systems may struggle to scale efficiently and effectively, and hindering the ability to handle the growing amounts of data and computational demands. As of today, we are having people with a large number of gene sequencing and a large number of data sets which cannot be handled by the traditional computers. So by using this quantum computing, which can handle the large data, which can provide the data within if the traditional computers are able to produce that compute the data, if it takes 1 year, by using this quantum computing we can generate the outputs within 2 or 3 hours, or within 2 days. In this way, the quantum computers are able to effectively produce the results in a less time. Inability to model quantum systems. And classical computers are inherently limited in simulating quantum systems, which play a crucial role in understanding a molecular interaction at a quantum level. Quantum effects can significantly impact the behavior of the molecules, and classical computers might miss these nonsenses. That's why we can, it is the ability to model the quantum system is more efficient. And coming to the limited parallelism, classical computers rely on a sequential processing, while many drug discovery tasks would benefit from parallel processing capabilities. It means just like a pipelining. In the traditional methods, if one process is done, again we have to go for next. We have to wait for the previous process to complete. Whereas in the quantum computing, we can do it in a simultaneous process. That's why quantum computing directly supports the parallelism. So quantum computers inherently exhibit parallelism, allowing them to explore multiple solutions simultaneously. So if you see comparing with the traditional system, the limitations of classical computing and drug discovery highlight the need for more powerful systems. That can be a quantum system, and quantum systems provide more computational process which are efficient than the traditional classical algorithms. And coming to the quantum computing in drug discovery, here while quantum algorithms have made strides, there are pressing needs for the improvement to address the specific challenges in the evolving diseases. So progress has been notable, but refinement is essential for a broader application. So that's why I have proposed an algorithm. I'll share you my paper so that you can better understand what I'm going to discuss. So this is the paper which I have written on the quantum computing. And coming to the proposed model, this is the proposed model. In the proposed model, I am going for the, this is the figure. This is the initial phase: model development, noise mitigation, scalability. It means coming to the algorithm steps typically involves a series of well-defined instructions to solve a particular problem in the drug discovery, while the specific steps depend on the algorithm and its purpose. Here, coming to the initialization, in this initial phase, set up any necessary data structures, variables for parameters required for the algorithm. So what might be the initial parameters, and what are the data set actually we required? Here we are having a gene sequencing like a PubMed data sets, which can be taken for the processing for the drug discovery. Giving the input, acquire the input data or values needed for the algorithm to process. And we have to pre-process the data so as to give the clean data, which is where we have to avoid the missing values. Or if the data is missed, if there is any noise in the data, we have to pre-process the data. So we have to produce in order to produce the accurate results. And Coming to the module development, here we are having a module which can avoid the noise mitigation and the stability enhancement module, algorithm optimization module. So in a noise mitigation module, which is used to reduce the noise, and thus scalability is which can provide which is more efficient, and which for the large systems it can provide the efficient results. And we have to use an algorithm which can provide algorithm optimization. It means based on the parameters which we are going to use, that can optimize the algorithm performance and it can give the accurate results. We have to integrate all the noise mitigation, scalability enhancement module, and algorithm optimization. And we have to integrate all the things, and UI, user interface designing, is providing. So based on the evaluation and feedback, if we are unable to get the proper results, and we'll give back to the feedback to the system, the results are not accurate. So based on the results which we have given, it will refine and optimize the system. And will based on the outcome will be monitored, and if we get the accurate results than the previous traditional algorithms, when we can give the reports and visualize the data. This is what my proposed algorithm, and there is a this is the actual working of the proposed algorithm. So here we are having some molecule data, which might be the PubMed data, or real world data can be considered, and we are able to do some quantum simulations on the data. And if there is any noise, as I told you, we have to apply the noise mitigation. If there is any noise is there, again we have to give back to we have to remove that noise, and we have to consider the data which is free from the noise, and we have to further proceed. And based on the large system, whether it can applicable for the large system or not. If it is able to perform on the large system, we can proceed. Otherwise, we have to apply the scalability and enhancement module, and we have to go to the previous step. And again, we have to go for the optimization. Based on the optimization algorithm, we have to proceed and evaluate the algorithm, and we have to refine the model. Based on the refinement, we are getting the accurate results or not. We have to check the results, and we have to visualize the system. And this is the algorithm which I have proposed. Initial quantum bits. Here we have to initialize the quantum systems. We have taken some qubits. As I told you, this is not an ordinary system to provide the binary values. Here we are using qubits, which are known as quantum bits, and we are having some quantum gates and initial state. For the initial state is given to the quantum system. And for the initial state, we have given CI. CI is nothing but the coefficient associated for the each term, and UI is the quantum gate. And we have given to the initial state. This is how we have to initialize the quantum system. And next we are coming some molecular Hamiltonian. The molecular Hamiltonian to describe the total energy of the molecular system. So here we are considering an equation, which is molecular Hamiltonian. This is the energy of the electrons present in the quantum system, and and the kinetic energy. Tn is the kinetic energy of the nuclei, and V is the energy operator. Based on this equation, we are able to formulate the molecular Hamiltonian, and this is a detailed equation of the molecular Hamiltonian. Like we are taking some of VE and VN and VEN. These are nothing but the summation of the electrical potential energy, nuclear repulsion energy, and electron nuclear energy. And here V is nothing but the potential energy operator. We are expanding just V values. Next, coming to the implement quantum algorithm for the molecular simulation. Here we are using quantum state, initializing optimal system, and molecular quantum, which we have defined in the above step, is using here. And we are able to apply the quantum evaluation. Here we are having, this is the equation for representing, here we are taking some Schrodinger's equation, which is able to identify the quantum state of the particular system. And this is the initial quantum state, which is represented by the 0. And if the state is based on the how many times we are iterating, the state will be improved. And this is the evolution loop. And we are expanding based on the sum of the Taylor series, and we are able to expand the equation if there is a scalability of the systems are more. And this is the noise mitigation we are using. For the noise mitigation, we are using a quantum formula, and this is the formula for the noise mitigation. And next, we are able to apply the noise mitigation formula to the entire system. And if there are multiple systems, just like scalar systems, we are able to apply this. Scaling to the larger system, if there are multiple systems, we are able to apply the things, and we are able to, and we are optimizing the system. This is the design optimized quantum algorithm. and we are able to optimize the system, and this is the based on the feedback we are iterating the loop, and we are able to get the accuracy results. That's why we are taking this iterative optimization. And quantum measurement, this is how we are performance measurement is doing based on the results, and we are able to get the accuracy correctly or not. This is how we are able to measure and analyze the performance quantum measurement. And this is the iterative research. If there is any we are unable to get the accurate results, again we have to go and check the feedback, and we have to take the pre-processing, or we have to change the hyperparameters to tune the tuning parameters of the particular model to get the proper results. And I have done everything, and this is the experimental results which I have considered. I have taken some of the QNN, QSM, QDT, and random forest. And if I take some PubChem data set, these are the accuracy results. This is the proposed quantum neural network, quantum SVM, support vector machine, data decision tree, and random forest. And based on this, we are able to identify that this quantum neural network is able to provide the best results on any data set. That's why I have considered this quantum neural networks for this particular drug discovery also. And next, I have taken some of the data sets. The proposal model is applied on the different data sets like which are binding database, TOX21, MUV. These are the some of the data sets which are having some gene sequencing data sets. I am able to apply these three algorithms differently on these three data sets, and I have observed that the quantum neural network has given very good results. And this is just like a comparative analysis, and I have observed few things. The comparison of the performance metrics of the quantum neural networks with the traditional quantum machine learning algorithms are, these are typically able to provide 99% above accuracies, and these are some of the less things. And quantum volumes also, these are able to utilize the higher quantum volumes. These are limited to some of the volumes are limited, and this random forest is unable to perform on the high data sets, and error rates are also very less, and gate and measurement times also very fast with these quantum neural networks or else any quantum algorithms. And scalability also very high, and algorithm success rates also very high for these quantum neural networks, and quantum speedups also very high. And variational quantum for convergence also coming to the convergence, it means reducing the error rates also very high with the quantum neural networks. And entanglement and entropy and resource requirements, chemical accuracy, parallelism, these are also very high with the when compared with the quantum support vector machines, decision trees, and random forests. We are able to get very good accuracy and higher parallelism with the quantum neural networks. And I have taken some of the, this is the overall performance. This is quantum neural networks is providing superior performance, and these are the some of the advantages which I have considered. And coming to the conclusion, we came to know that the quantum neural networks are able to provide the higher results. And based on this study, some of the latest research topics in quantum drug discovery, to my knowledge is, as my knowledge, this can be used as a quantum machine learning for drug design also. So investigating in the quantum machine learning algorithms to enhance the analysis of biological data and improving drug design processes is one of the future trending drug discovery research proposal. And coming to the quantum chemistry simulations also, and developing an advanced quantum algorithm for simulating molecular structures and interactions, enabling more accurate predictions for drug behavior. This can be worked in the future. As of now, research is going on the chemistry simulations also by using quantum. And next one is quantum optimization for drug candidate selections. This is what we have done by using this quantum neural network, exploring quantum optimization algorithms to efficiently search the large chemical spaces and identify optimal drug candidates. This is what we have done now. And quantum enhanced molecular dynamics, utilizing quantum computing to enhance molecular dynamics simulations, providing a deeper understanding of the dynamic behavior of biological molecules. And a hybrid quantum classical approaches. Here some of the hybrid means we are just like ensemble methods, like integrating quantum and classical computing techniques to address the specific challenges in drug discovery, combining the strengths of both the paradigms and able to produce a high accuracy. And we can also go with the future like a quantum correction in drug discovery applications, addressing the inherent challenges of quantum systems such as noise and errors through the development of robust quantum error correction methods for drug discovery applications. This is a more efficient, which was the trending technology right now for the future research scope in the quantum computing and quantum computing applications in pharmacogenomics, like investigating how quantum computing can contribute to the analysis of genomic data for personalized medicines. As of now we discussed, we are using all the medicines commonly, but when we have a more development based on the body structure or biological combinations, we can personalize the medicines and drug response predictions also can be done. And this is how we can use quantum drug discovery efficiently for the future process. And these are the main what I have developed a model, and what my observations for the future scope. And these are the some of the references I have used. And this is regarding my topic. Thank you. If you have any doubts, you can ask me now.
Thank you, madam. Very nice presentation, madam. Thank you,
Thank you,
madam.
sir.
Sir, any other questions from audience? Hello? 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 Any questions from audience? Sir? Dean, sir? Hello, sir. Are you there?
Sir?
Sir, ma'am completed, sir.
Okay, okay, sir. Okay. Thank you, madam. Thank you. Thanks for joining us and deliver a very good talk. And mostly it was content chemistry associated with the program developed by you. So let us move on to the oral session, sir.
Yes, sir. 11:30 already we have given, sir.
Scheduled.
Yes, sir.
Okay. What about
Yes, sir. Now we will start, sir. No issue.
the session chair for this session?
Session chair.
I think.
Yes, sir. Jayasri Jain, Jyoti, who are there?
Have they joined, sir?
Yes, sir. Mathematics Sri Lada, madam. But I said 11:30. Sir, remaining all I will inform, sir. Now. Jayasri, madam.
Okay. Ask them to join, sir.
Yes, sir. Yes, sir. Jayasri and Jyoti, both I will inform now, sir.
Okay.
Okay.
Dr. Srilada has joined us, huh?
Sir, Sri Lada Mathematics, sir. 11:30 I
Oh,
said, sir.
okay.
Thank you so much, sir.
Thank you, madam. Thank you very much. Thank you, madam.
Thank you, sir. Bye, sir.
Okay, the computer science people, please keep in same track one, same. Mathematics people, please join track two.